Have you ever asked an AI a question only to get an answer that's confidently, completely wrong? Well, you're not alone. And today, we're going to pull back the curtain on the technology designed to fix that. It's called Retrieval-Augmented Generation, or RAG for short. Think of it as giving AI a library card to the entire real-time world. So let's get right to it. Why do these super smart large language models sometimes just get things wrong? Well, at their core, LLMs are incredibly powerful, no doubt. But here's the catch. Their knowledge is totally locked into whatever data they were trained on. So the real question becomes, what happens when that data just isn't enough? Well, you basically hit three huge roadblocks. First, you've got hallucinations. And yeah, that's the technical term for when the AI just makes stuff up. Then there's the fact that its knowledge is basically frozen in time. It can't tell you about anything that happened after its training data was collected. And finally, these things are often total black boxes, right? You get an answer, but you have no idea how it got there. And that's exactly where RAG steps in. It's such an elegant solution. It basically gives an LLM a superpower, the ability to look things up in real time. So before it even tries to answer your question, it goes out, finds relevant, up-to-date information from some external source, and uses that to build its answer. It grounds the response in actual, verifiable facts. All right, so here's the game plan for our journey through the evolution of RAG. We'll kick things off with why it was even created and get into the basics with the naive RAG pipeline. From there, we'll see how it gets smarter with advanced retrieval techniques. And then, this is the cool part, how it learns to think for itself with self-correcting RAG. After that, we'll look at some really specialized architectures and wrap up with how we optimize and evaluate these complex systems. Okay, let's dive in with the naive RAG pipeline. This is the foundation, right? The classic, original process that everything else we're going to talk about is built on. So at its heart, this naive RAG is a pretty straightforward three-part flow. It's a simple, linear process. You index your data, you retrieve what's relevant, and then you generate the answer. Super simple, but honestly, incredibly powerful. So let's really break that down. How does it work? Well, first up is indexing. This is where you take a big pile of documents, chop them up into smaller chunks, and turn them into numerical representations. We call those embeddings, and store them in a special vector database. Step 2 is retrieval. Your question gets turned into a number 2, and the system hunts for the document chunks that are the most similar, mathematically speaking. And finally, generation. The original question and those chunks you just found get sent to the LLM, which uses them to craft a context-aware, fact-based answer. Okay, so naive RAG was a fantastic start, but it had its limits. And that, of course, led to the next step in its evolution, advanced retrieval techniques. This is where the whole process starts to get a whole lot smarter. So what's the big change? Well, while naive RAG was just that simple linear flow, advanced RAG starts adding new, absolutely critical stages before and after that main retrieval step. You get these pre-retrieval and post-retrieval modules. And the whole point of these is to seriously improve the quality of the information that the LLM finally gets to see. But why bother with these extra steps? Well, here's the problem. With the naive approach, it's kind of garbage in, garbage out. If you ask a vague or just poorly phrased question, you're going to get a poor retrieval. And that means you're going to get a pretty useless answer. And that's where these pre-retrieval techniques, like query transformation, are a total game changer. So instead of just taking your question at face value, the system might generate a few different versions of it to cast a wider net. Or, and this is where it gets really clever, there's a method called HyDE. It actually generates a fake, hypothetical answer first, and then it uses that fake answer to find the best documents. Now, why on earth would it do that? Well, a detailed answer is way more likely to share important keywords and context with the source documents than your short question is. It's a seriously brilliant trick to boost relevance. And the optimization doesn't even stop there. You've got things like hybrid search, which combines, old school keyword searching with modern meaning-based or semantic search. It gets you the best of both worlds. And after the documents are found, you can add another step called re-ranking. This intelligently reorders everything it found to make sure the most relevant stuff is right at the top before it ever gets sent to the LLM. All right, so we've made the retrieval part smarter, but now we're getting to what I think is the most exciting leap forward. Building a system that can actually evaluate its own work and correct its own mistakes. This is self-correcting RAG. So check out this quote from the researchers behind a system called self-RAG. They make a really crucial point. Just blindly grabbing a bunch of documents and stuffing them into the prompt, well, it doesn't always work.
Sometimes that information is totally irrelevant, or even worse, it can be misleading. So what's the fix? You have to build a system that has a layer of judgment, an AI that can actually stop and ask itself, wait a minute, do I even need to do a search for this? And if I do, are the results I got back any good? This whole idea has led to some amazing new methods. You have adaptive RAG, which first decides if a search is even necessary or if the LLM already knows the answer. Then there's corrective RAG, or CRAG, which actually grades the quality of the documents it finds. And if they're junk, it can just decide to do a web search instead as a fallback. And then there's self-RAG, which goes even further. It uses these special reflection tokens to basically critique its own answers for things like relevance and factual accuracy before it ever shows them to you. It's wild. Okay, so with all this new intelligence, RAG can now move way beyond simple Q&A. It's starting to tackle much more complex data, and this is where we see the shift into these really specialized architectures. One of the coolest ideas here is called Agentic RAG. Forget the simple linear pipeline. The system now acts more like an intelligent agent. It can come up with a plan, use different tools, search multiple times if it needs to, and refine its approach on the fly to solve really complex, multi-step problems. I mean, this is a huge leap in what these systems can do. And then there's another fascinating twist, Graph RAG. Standard RAG just finds isolated chunks of text, right? Well, Graph RAG pulls its information from a knowledge graph. What's so cool about that? It means the system doesn't just understand individual facts. It understands the relationships between those facts. And that unlocks a much, much deeper level of reasoning. And get this, RAG isn't just for text anymore. We now have multimodal RAG, which can process and pull together information from video, audio, and images. So it could, for example, watch a video clip, listen to what people are saying, and figure out what they're probably planning to do next. It can see and hear the world. So, as you can imagine, when these things evolve from simple pipelines into these super complex multi-part systems, a whole new set of challenges pops up. Like, how do you manage all these moving parts? And, maybe more importantly, how do you even know if the whole thing is actually working well? Let's talk about optimization and evaluation. Well, the solution is to use dedicated evaluation frameworks. There's a tool called RAGAS, for example, that's designed specifically to measure the quality of both the retrieval part and the generation part. This gives developers the critical feedback they absolutely need to fine-tune these really complex systems. And that really brings us to the single most important takeaway from all of this. We have to stop thinking of RAG as just a simple trick or some kind of add-on. At this point, with everything it can do, it's really become a complete, complex, and powerful AI system all on its own. So that leaves us with one final big question to think about. We've just watched RAG evolve from a pretty simple fix for hallucinations into this incredibly sophisticated reasoning engine. As it keeps growing into an entire system, the real question isn't just about what new problems it can solve, but what new challenges and what new opportunities its very existence is going to create.